We've learned that if you've got congruent chords of a circle or congruent chords in congruent circles, that the arcs that are created by those chords are also going to be congruent. Now we're going to take the flip side of this, where we've got congruent arcs, and that would mean that the chords themselves are also congruent. So in this, looking at this diagram and then also this explanation, it says in circle W, and we see circle W right here. We got the midpoint of the circle is defined as W, that's circle W, that the arc RS is congruent to the arc TV. And then we're asked to find the length of the segment, the chord RS. Well, if arc RS and arc TV are congruent, then their chords are also congruent. And so the first thing we would need to do in order to find the length of the chord RS is to find the value of X. And since these two chords are congruent, then they're equal. And we can say then that 5X minus 9 equals 2X plus 3. And so why don't we subtract 2X from both sides and add 9 to both sides. And so let's see, 5X minus 2X is going to result in 3X. And 3 plus 9 is going to equal 12. And let's divide both sides by 3. And when we do, X is going to equal 4. Well, that gives us the value of X, but what is RS? Well, RS, we're told, is equal to 5X minus 9, which means then we can substitute in 4 for X, and so that's going to be 5 times 4 minus 9, and 5 times 4 is 20, minus 9, and so then RS is going to equal 11 units of something, although that's not been defined for us. All right, so first we looked at congruent chords to find the measures of the arcs, and this time we took the fact that the arcs are congruent, and we could use that to find the measure of the chords, since the chords are going to be congruent, and shazam, we've done it.